Campus Access exam objectives. Let me briefly go through each one to move onto the lower bandwidth channel width, such as 10 to 20 MHz, to reduce the interference. Setting on split recovery is on. The default configuration setting on split recovery is on specific attributes. If you have a integration with a radius server that supports VSA attributes, then hello everyone, welcome to today's online class from 591lab.com. Today we will be discussing sample questions of Aruba Certified Professional Campus Access exam. In this session today, we will understand few concepts related to Aruba wired and wireless solutions. Before I move on, let me introduce the 591lab.com. 591lab.com is the top IT training and certification exam brand in China, Hong Kong, Taiwan and Singapore. Our mission at 591lab is to provide our clients with exceptional exam preparation experience for certifications in Cisco, Huawei, Aruba, Juniper, Palo Alto and Fortinet exam tracks. Today we will be covering few topics such as wireless LAN, switching, routing and security from Aruba Certified Professional Campus Access exam objectives. Let me briefly go through each one of them. Under wireless LAN, topics related to wireless functions and how to build configuration based on customer requirement are included. Then switching includes the implementation of layer 2 and layer 3 technologies and how to validate them. Routing covers the implementation of routing topologies and functions. The knowledge related to security standards, concepts and Wi-Fi authentication methods are covered under security. Okay, let's look at the sample question under wireless LAN. What is the primary benefit of BSS coloring? Question is about BSS coloring. Let's understand what is BSS coloring. BSS stands for Basic Service Set. Let me show you Aruba white paper on 802.11ax, which is Wi-Fi 6. This is the Aruba white paper on 802.11x. As you know, we have only 3 non-overlapping channels in 2.4 GHz band. They are channel number 1, 6 and 11. But we have more channels in 5 GHz band. But in case of high user density environments, we may need to place APs close to each other to cater the capacity. Then APs on the same channel will interfere with each other. It may not be possible to use 40 MHz channel width in 5 GHz if there is a high number of APs placed close to each other. Then we have to move on to the lower bandwidth channel width, such as 10 to 20 MHz, to reduce the interference. What I mean here is, if you do channel bonding to have higher bandwidth channels, the number of channels get reduced. Therefore, is there any mechanism to operate with bonded channel width like 40 MHz or 80 MHz but minimizing interference? Yes. The answer is yes. So the solution is BSS coloring. So look at this image. This is the right image to which explains the BSS coloring and the effect of BSS coloring and the effect of absence of BSS coloring. So BSS coloring mechanism will assign a color tag to a channel so that it will reduce the possibility of nearby APs having same color on same channel. Thus nearby APs on same channels can transmit same time as long as they have different colors. So this is the logic here. In the image you can see on left hand side without BSS coloring. So APs on channel 1 are interfering with each other, but on the right hand side with BSS coloring the interferences are minimized as APs on same channel have different colors. So hope you got the idea. Let's look at the answers. Option A. BSS color tags improve security by identifying rogue APs and tagging them as threats. That's not relevant to what we have discussed and it is wrong. Option B. BSS color tags are applied on the wireless controllers and can reduce the threshold for interference. Color tags are applied to channels, not on the wireless LAN controllers. This is wrong. Option C. BSS color tags improve performance by allowing APs on the same channel to be farther apart. No, BSS coloring will allow the APs on same channel to be closer, not to be farther apart. So this is wrong. Option D, BSS color tags are applied to Wi-Fi channels and can reduce the threshold for interference. Yes, it is exactly what we read in the white paper. Look here, BSS coloring allows the network to assign a color tag to a channel and reduce the threshold for interference. Therefore, the correct answer is option D. Take a look at the next question under wireless LAN. For an Aruba AOS 10 AP in mixed mode, which factors can be used to determine the forwarding role assigned to a client? We have to select two answers. In AOS 10, AP in mixed mode means based on the VLAN assigned, AP would bridge the traffic or tunnel the traffic to the gateway. Look at this explanation in Aruba documentation on mixed forwarding mode. When mixed traffic forwarding is configured in a wireless LAN or downlink wired port profile, the client traffic will either be directly forwarded out of the AP's uplink onto the access switching layer with the appropriate .1q VLAN tag or encapsulated in GRE by the APs and tunneled to the primary gateway cluster using the following forwarding modes. So either it will be bridged or tunneled to the gateway. Okay, question asks about the factors that will be used to decide the forwarding role to a client. In other words, this is about how the roles are derived. Let's look at the Aruba documentation on user roles. Let's go through the roles one by one. First one is initial user role. The initial user role or VLAN assigned for the unauthenticated clients. This role or VLAN is assigned for a client who is not authenticated. So purpose is to initially assign a VLAN or role so that it has basic connectivity and can proceed with the next workflow. Then user derived role. This is derived based on user attributes such as MAC address. Then default user role. The default user role configured for an authentication method such as .1x or VPA. You can configure a default role for the clients that successfully authenticate based on the specified authentication method in the SSID. And server derived role. The user role can be derived from attributes returned by the authentication server. This is assigned for a client after authentication is complete and can be based on one or more attributes returned by the server during authentication. VSA derived role. This is based on vendor specific attributes and to provide features that are not supported in standard radius attributes. Now you have a basic idea on user roles and how they are derived. We'll go through answers. Option A, client IP address. Client gets final IP address after the final role is assigned. So this couldn't be a decision maker to derive role. This is wrong. Option B, 802.1x authentication result. Server derived role or VSA derived role is assigned based on the authentication result. So this looks correct. Option C, client SSID. SSID is not a decision maker to derive a user role. This is wrong. Option D, client VLAN. Client VLAN is assigned after the forwarding role is decided. So it is not a factor to decide the forwarding role. This is wrong. Option E, client MAC address. Client MAC address is an user attribute that can be used to derive user derived role. This is correct. So correct answers are option B and E. We'll move on to the next question, switching. You are proposing new Aruba 8360 VSX switches to replace a customer's existing core switches. The customer is concerned about the possibility of a split brain scenario between the VSX pair. How is the VSX pair affected when the ISL is down and keep alive is down? This is about VSX split brain scenario. Let's look at the VSX architecture and its components. Here you can see two AOS CX switches have ISL links between them and a dedicated keep alive link as well. This document explains the impact on various failure scenarios like ISL down but keep alive is up and keep alive down but ISL up, and both ISL and keep alive are down. So in our scenario, ISL link is down, keep alive link is also down. So the default setting on split recovery is on. the default configuration setting on split recovery is on. So this is applicable in our scenario. ISL down and keep alive also down. What is the result? All VSX leg ports stay up. So this is the outcome in this split brain scenario. Then all VSX leg ports stay up, so traffic can be passed through. This is the split brain scenario, as both switches will pass traffic because they don't know about each other. So this results in asymmetric traffic flow and data loss. Let's check the answers. Option A. The VSX node with higher uptime continues forwarding. There's no such condition mentioned in the document we have seen. This is wrong. Option B. Both VSX nodes will automatically reboot and keep leg interfaces shut down. Nothing mentioned like that. This is also wrong. Option C. The VSX node with lower system ID continues forwarding. No such system ID related traffic forwarding decision. This is not correct. Option D. Both VSX nodes still forward traffic. Yes, that's what document says. In the split brain scenario with the ISL down, keep alive down, then all the legs stay up. So both VSX nodes are forwarding traffic. So this is correct. The correct answer is option D. Let's look at the next question under switching. You are configuring an SVI on an Aruba CX switch that needs to have the following characteristics. So the characteristics are given like this: VLAN ID equals 25, IPv4 address 10.105.43.1 with mask 255.255.255.0. Then there's IPv6 address given with 64-bit prefix length. It should be member of VRF ENG, VRF ENG and VLAN 25 have not yet been created. So those are the characteristics given. Which command lists will satisfy the requirements with the least number of commands? Okay, we have to focus on creating VRF and VLAN ID and then assign the given IPs. I'll refer the Aruba AOS CX IP routing guide. How do you create VRF? This is the syntax. We command VRF and then the VRF name. This is the syntax you have to use when you create VRF. Look at this example. This is how you create a VLAN and attach that VLAN interface to a VRF. So here you are creating a VLAN 3. Then this interface VLAN 3 is attached to the VRF called test. This is how you do these things. IPv4 and IPv6 addresses are configured under interface with prefix length. IPv4 address and the prefix length. IPv6 also the address and the prefix length. So they are configured under the relevant interface. In our case, it is the VLAN interface. So now we know the commands used for this scenario. Let's look at the answers. Option A. It is creating a VRF ENG, then VLAN 25. Okay, under interface VLAN 25, you are attaching the VRF ENG. And after that, you are defining the IP address with the prefix length and IPv6 also. All the commands are in order and this looks correct. Let's check the others. Option B. VRF ENG correct. Correctly defined. VLAN 25 defined. Interface VLAN 25. Then IP addresses are configured. At the end, they are attached in the ENG. Here the VRF binding to the SVI is done at the end. By default, all the interfaces are attached to the VRF default. So if you are changing it to a user-defined VRF, that is ENG, then the previously assigned IPs will be automatically removed from the interface. Therefore, VRF binding has to be done before assigning the IP address. So the option B is wrong. Option C, here VRF ENG and VLAN 25 correct. Interface VLAN. Here there are two mistakes. First is IPv4 address is configured with mask in dotted decimal format, which is wrong. It has to be with prefix length. Second mistake is VRF binding was done after IP address assignment. Option C is wrong. Option D, VRF and VLAN ID were not defined initially. This is wrong. So correct answer is option A. Next question is from routing. Which statements regarding OSPF version 2 route redistribution are true for Aruba OSCX switches? We have to select two answers. I'll check the AOSCX IP routing guide for OSPF version 2 redistribution. In the redistribute command syntax, you can see options like BGP, connected, local loopback, RIP and static RIP and OSPF. Those are routing domains that can be redistributed into OSPF version 2 and can bind the route map to control the redistribution. So we have to go through answers and check whether they are correct or not. Option A, the redistribute static route map connected routes. Command will redistribute all static routes with a matching permit in the route map connected routes. This command shows redistribution of the static routes with a route map called connected routes. Route map could be like this to match a route that need to be redistributed. So this option looks correct. Option A looks correct. Option B, the redistribute connected command will redistribute all connected routes for the switch, including local loopback addresses. If need to redistribute local loopback addresses, then need to use the command redistribute local loopback. Redistribute connected command will not redistribute local loopback. These two commands are independent. This is wrong. Option C, the redistribute static route map connected routes. Command will redistribute all static routes without a matching deny in the route map connected routes. If the route map contains deny entry, then that route won't be available for further processing. Only the entries with permit are allowed for further processing if matched. This is wrong. Option D, the redistribute OSPF command will redistribute routes from all OSPF version 2 and version 3 processors. Question is about OSPF version 2 route redistribution. So the redistribution OSPF command is applied under OSPF version 2 process or OSPF version 3 process. Then only OSPF version 2 routes or OSPF version 3 routes will be redistributed into the relevant process, but not both version 2 and version 3. So this is not correct. Option E, redistribute connected command will redistribute all connected routes for the switch except local loopback addresses. Yes, it will redistribute all connected routes except local loopback. As you saw earlier, there is a different command specifically for local loopback redistribution. This is correct. So correct answers are option A and E. Let's look at the next question under routing. You need to have different routing table requirements with Aruba CX6300 VSF configuration. Assuming the correct layer 2 VLAN already exists, how do you create a new OSPF configuration for a separate routing table? Question is related to OSPF configuration for a new VRF. Let me show you a sample configuration from Aruba IP routing configuration guide. You can see how the OSPF process is created. If you don't specify VRF name, then by default it is under default VRF. You can see here a new VRF called red has been created, and when defining the related OSPF process, VRF name is attached to that. When you define the route OSPF 1, this VRF red is attached to that OSPF process. This is how the OSPF process and the VRFs are associated. We'll check the answers. Option A, SVI is attached to VRF will automatically map OSPF to the same routing table. If SVI is attached to a VRF, then only the SVI will be in that VRF, but it will not map OSPF process automatically to the new VRF. So this is wrong. Option B, attach a new OSPF process ID with a custom routing table. Yes, that's what we have seen in the guide, in the example. When you create the OSPF process ID, you attach the new VRF. This looks correct. Option C, create a new routing table and attach OSPF process ID to it. When you define the new VRF, there's no option under VRF configuration to attach OSPF process ID. This is wrong. Option D, attach OSPF process ID in the VRF configuration. This is also similar to option C with rephrasing the same idea. Cannot attach OSPF process ID in VRF configuration. This is wrong. Correct answer is option B. Okay, we'll move on to the next question from security. List the firewall role derivation flow in the correct order. So you can see some firewall roles. There are 4 firewall roles. So we have to put them in the correct order, how they derived. Look at this role derivation flow from Aruba documentation. So initial role is the first role. It's a pre-authenticated role, always assigned to a new client when the client is associated with the SSID. So then the second role is user derived role. So based on some user attributes like MAC addresses, so this user derived role is assigned. So after that, VSA derived role, vendor specific attributes. So if you have a integration with a Radius server that supports VSA attributes, then VSA derived roles can be assigned. So this is the third VSA derived roles. So then after that, server derived roles, the legacy Radius server derived roles. So at the end, if there is no specific server derived or VSA derived roles are assigned, then the default role is assigned to the client. So this is how the firewall role derivation happens. So now we are able to put these firewall rules in the correct order. So the first one will be the initial role. This is number 1. Then user derived role. Then the third one is server derived role. So if there are no server derived role, authentication default role. This is how the firewall roles are derived, and we have put them in the order. Next question from security. What is the classification in wireless IDS IPS for an unauthorized AP which has only been seen on the wireless network? To explain this, I believe Aruba Central Dashboard is the best tool to use. Let me show you Aruba Central Dashboard here. Go to security and then check the rogues. You can see some rogues and interfering APs, some rogues. If you click on them, you can see more details such as which AP has seen them and what time. If you click on here, you can see these more details, which AP has seen them and when it was first seen and last seen. All these details are available. Here you can see these classification: interfering APs, suspected rogues and rogues, neighbors. All these are classified devices. So let's look at the Aruba documentation for the classification terminology. This is the Aruba documentation for classification terminology of these rogue APs. So you can see authorized means an AP that is part of the enterprise providing wireless services. So neighbor means a neighboring AP is when the BSSID are known. Once classified, a neighboring AP does not change its state. Interfering AP, an AP that is seen in the RF environment but is not connected to the wired network. An interfering AP is not considered a direct security threat since it is not connected to the wired network. For example, an interfering AP can be an AP that belongs to a neighboring office wireless LAN but is not part of your wireless network. Rogue, an unauthorized AP that is plugged into the wired side of the network. Suspected rogue, a suspected rogue is an unauthorized AP that may be plugged into the wired side of the network. Contain means an AP which denial of service is enabled manually. So this is the classification terminology. Question asked about the unauthorized AP has only been seen on a wireless network. So it is quite clear. The answer is interfering AP. So the correct answer is option A. Okay, that concludes our training for today. I hope you found this overview of Aruba Certified Professional Campus Access exam topics helpful. We have discussed sample questions covering the areas such as wireless LAN, switching, routing and security. Be sure to check out 591lab.com for more online courses, practice exams and training materials to continue your certification preparation. You can also visit www.591cert.com to learn more about our full suite of services. If you have any questions or concerns, please don't hesitate to contact us. Thanks for joining today's class and I wish you the best of luck on your certification journey. Have a great day.